We're solving problem 19 from the 2020 AMC 12B. Square ABCD in the coordinate plane has vertices at the points A equals 1, 1, B negative 1, 1, C negative 1, negative 1, and D 1, negative 1. Consider the four transformations. L, a rotation of 90 degrees counterclockwise around the origin. R, a rotation of 90 degrees clockwise around the origin. H, a reflection across the x-axis, and V, a reflection across the y-axis. Each of these transformations maps the squares onto itself, but the positions of the labeled vertices will change. For example, applying R and then V would send the vertex A at 1, 1 to negative 1, negative 1, and would send the vertex B at negative 1, 1 to itself. How many sequences of 20 transformations chosen from the set L, R, H, and V will send all of the labeled vertices back to their original positions? So the first thing to look at in this problem is, well, we have this square, and we have 20 transformations and 4 transformations you can apply for each transformation, like 4 ways to transform it. So therefore, the total number is going to be 4 to the power of 20. But in the answer choices, most of the answers are shown in powers of 2. So we want to convert it into powers of 2. So you just multiply the power by 2. This becomes 2 to the power of 40. Now you want to find what doesn't work. And the thing you can do here is count. Point A is in quadrant 1, point B is in quadrant 2, point C is in quadrant 3, and quadrant D is in quadrant 4. So when we apply, say, this rotation, or L, this transformation rotates counterclockwise around the origin, A goes to point B, which is an even number quadrant. When you rotate 90 degrees clockwise around the origin, goes to D, which is also an even quadrant. Same things when you reflect the point or the square across the axis. Say point A, it always goes to an even quadrant at first. Then if you apply at the next quadrant, it goes to an odd, and so forth. So basically, all that matters is that, well, it goes even, or in this case, odd, even, odd, even, odd, even. And since there are, well, every even and odd number repeats after the 1, and 20 is a multiple of 2, we know that, say, point A is gonna land in either odd quadrant. We just don't know if like point B will be where point B is right now. So the chances of point B landing in here is 1/2, and the chances of point B landing right here is also 1/2. So 1/2 times 1/2 is equal to 1/4. And when you take 1/4 of 2 to the power of 40, 2 to the power of 40 times 1/4, which is 1 over 2 squared, this becomes 2 to the power of 38 ways. So this is our answer for this problem, just 2 to the power of 38 sequences that sends the square to its original shape.